This is the real Tom Rose, and we are given a couple of statements, and the question is asking about the logic of those two statements and whether one implies the other, or vice versa. So this is, interestingly, I personally find it easiest to start here just looking at the statements and trying to figure out, is there any relationship between them? Does one imply the other or vice versa? So the first thing that jumps out at me, and I recognize this because I've seen some inequalities combined this way in the past. We have two inequalities, right? And notice that if you take the two smaller pieces, so A plus B, right? It's the small side and the small side. That will always be less than the big side plus the big side, C plus D. Right? If I take two smaller things and add them, they'll always be two smaller than two big things. So this is the first equation then. So that's a good. So first of all, just memorize that you can combine inequalities that way. You can add the small sides together and the big sides together and set them less than or greater than one another that way. So now that I know that this is true, you can stop here and pick Q implies P. Right? That is true, so this must be the correct answer. You can't have two correct answers, so you can't. This second one actually could never really be the answer, because in order for that to be the answer, Q would have to imply P, which would mean the third one would be the answer. So, but let's academically, let's just go on and see, does P imply Q, right? Because maybe you thought that it did. Well, the way that it's much easier to prove that it does not, because if you can simply find one case of numbers that satisfy P but that violate Q, then you know that P does not imply Q. So what I'm going to do is try to stack the deck and find a number that way. And specifically what I'm going to do is I need to make the left side smaller on P, but I want to make one of these false. So I'm going to try to make, for example, B, let me switch to a different color. I'm going to try to make B bigger than D. All right, let's say B is 5 and D is 4. Right? How can I make the left side smaller than the right side? Well, let's make A 1 and let's make C like 50. Right? So, and this is A, B, C, and D. So is the left side smaller than the right side? Yes, 6 is less than 54. Is B less than D? Is 5 less than 4? No. So if B is not less than D, then P does not imply Q. Or you could think of this as saying P does not guarantee Q. So that gets rid of both of those. Contrapositive is, we can also get rid of this one because we know one of them does apply the other. Contrapositive is not appropriate here. The contrapositive is a logical thing which says, if A implies B, then not B implies not A. It's a complicated thing. It's not appropriate here. You don't ever have to figure it out in order to answer this problem correctly. But contrapositive is kind of interesting. So if you're interested academically, go ahead and look that up, and you'll see some examples that explain this. They're kind of cool.